Our presenters today feature Georgia's rapid replacement utilizing full-depth precast deck panels with UHPC closure joints. We're pleased to welcome our presenters, Bill DuVall, State Bridge Engineer with the Georgia Department of Transportation, and Dexter Whaley, Bridge Design Group Manager with Georgia DOT. Bill?
Thank you, Mary Lou, and thank you to the panel for inviting us and letting us have the opportunity to talk about this project. And that's a mouthful. It's a big title. We had to shorten it down from what we had before, but anyway. This is a project that we did complete last July. The construction of it. We were pretty excited about what we were able to accomplish. And Dexter designed this project, and he's going to go through the process of the construction and what we learned from it. I think that's a big takeaway that you'll gather from the presentation. But before I get too far into it, I mean, Georgia is I don't know if we want to say experimental in ABC. I mean, we've done some ABC work over the years, and we certainly keep building a toolkit for ourselves and trying to just take these technologies and put them to use. And let's see, I want to make sure I'm on the right page here. So I'm going to talk a little bit about where we've been over the past few years, and then where we're going to go in the future. So part of where we've really started into ABC was with our bridge maintenance section. We have I just wanted to show you, this is a close-up map of Atlanta, and the shrouding perimeter, I-285, is about, in circles Atlanta, it's about a 64-mile loop around it, and that loop up in the north part of the loop can handle up to about 250,000 vehicles per day. So when you have to do work on that interstate, it really impedes traffic. So back in 2005, we had a project that was completed where we used exodermic deck panels to rapidly replace the bridge decks on two bridges. You can see them up there. It's 285 over Cobb Parkway, and then the other one 285 over Buford Highway. And I just wanted to point that out, that a contractor over a series of weekends, we would do lane closures, not shut 285 down. We kept traffic open. The contractor would go in and remove portions of the deck and use the exodermic deck. And this is not uncommon. I mean, it's been used around the country, but this was our first use, and we used it here, and since then we've used it in a few other places around the state as well. But that really proved that doing accelerated construction with the traffic could be a real benefit to the state. Another one I'd like to mention is we had a project, had a bridge down in our coastal Georgia that had pre-stressed beams that was inundated by the tides, and eventually, as you can see, we had some pre-stressed beams where we had some corrosion. The pre-stressing strand just totally was totally corroded away, and we had to go in and another maintenance project, and the engineer that took on this project it came up with kind of I will call it a decked ashto beam type design, and they were able to prefabricate these. These are type 2 beams. We shallowed them up from the original beam so that we could get more clearance over the tides, and we're able to only shut the road down for 2 weeks, and that was a big deal for us. So a good opportunity, and certainly we want to try to take this technology and use it. Move it forward. This project was done back in 2013, I believe. Another project we did a number of years ago, this is, we had an interchange that was built south of Atlanta toward our Columbus area. It's about, I don't know, maybe 60 miles southwest of Atlanta, where Kia was building a manufacturing plant. We needed a new interchange, and as part of the construction, we decided to use, and it was a design-build contract, we decided to require the contractor to use precast columns and precast caps One is to, to minimize the disruption in traffic, but two, to really put this technology to use in Georgia and find out how well it worked. The contractor was C.W. Matthews, and the designer was Arcadis, and they completed this work back in 2009. I will say that this is also a project that is featured on the ABC UTC database, so if anybody wants more details, it's already available. This is a project, I put SPMT up here. This is a project that we have going on right now up in the northwest corner of Georgia. It's closer to Chattanooga. It's right outside of Chattanooga, actually. And this is a State Route 299 over I-24. Deficient bridge. There's truck stops on both sides of the highway. It's a big connector. We have a lot of traffic on there, so we decided that we wanted to do this bridge rapid replacement, and we let a design build contract to, and we gave the option. We told the contractor you had to either do a lateral slide or you had to use SPMTs. The contractor's Wright Brothers, and their engineer is WSP Parsons Brinkerhoff, and they chose a SPMT option, but they also what's shown here is they've built the temporary supports right next to the adjacent bridge. They're building they've got all the beams in place. They're getting ready to deck these two spans. And schedule right now, we're looking somewhere this spring, summer to do the 56-hour weekend closure. That's the only time that State Route 299 is going to be closed entirely. It's most likely will be a weekend in May. We'll see how that goes. But when they put the closure in, they'll remove one span over top of one direction of I-24. Place that span, switch traffic over, remove the other section of State Route 299, and place the other span, and have it open by Monday morning. So we're excited about that project and seeing it through. But Dexter's going to go ahead and talk about State Route 211. Now, when we're done with this, we are going to have our details, and we're going to push these out on the ABC UTC site as well.
Project was State Route 211 over Beach Creek. This about 50 miles or so northeast of Atlanta. And the reason for this bridge needed to be replaced was that, you see, it's posted, and the deficiency rating on this was below 50, so the bridge needed to be replaced. And so the little quick overview of the project here. It's a single span bridge, 148 feet long. It has a gutter-to-gutter width of 40 feet. And we're going to use full-depth precast deck panels on this bridge using UHPC for the joint connections. We had allowed a 60-day road closure for this bridge. Starting out, the road was closed for 60 days starting June 1st, but they were able to go in and clear and grub the right-of-way and put in a temporary work bridge before the actual closure. And so once they closed the bridge, it took them about 4 days to demolish the bridge and get it ready. And whenever I reference a day for this contractor, a day was typically 8 to 10 hour days. It was not a 24/7 type deal they were working. So they were basically working a normal 8 to 10 hour day. For our indents, we just used regular HP piles. And we allowed them to cast and place the end caps and the wing walls, and we allowed them to use 3,500 PSI 24-hour accelerated concrete. Again, because they were using just normal crews and not really an accelerated schedule, it took them about 7 days to form up both end vents and cast them in place. We used 72-inch bolt teed beams for this bridge. The beams were approximately 10,000 PSI strength, and one of the things the contractor really liked, we allowed them to use steel diaphragms, and so it took them a day to set the beams and took them a day to put the steel diaphragms in. And so that was a big positive. They really liked the use of the steel diaphragms for this type of application. Now, we used full depth precast panels. Our panels were 8 3/4 inches deep, and this allowed us to have our normal 2.5 inches or 2 3/4 inches of clearance on our rebar cover, but also gave us an additional 1/4 inch to grind for any unevenness in the panels as they were laid. We used number 5 bars across for both our longitudinal and our transverse steel, and the panels themselves were 4,500 psi concrete. We had 2 different size panels on the bridge. They were 8 or 9 depending on the location, and about 21.5 feet long. Here's our typical transverse joint here. We wanted to keep the joints as tight as possible, so we designed our opening here with a 2-inch top opening with a very tight bottom ear to act as formwork for the UHPC. And by using UHPC, we were able to get a 5-inch bar lap on our rebar. So instead of having normally a 1'9" or a 2'3" lap on our rebar, we were able to shorten this joint from 2 feet down to 6 inches. It was the total width of this open joint. And so, question is, why do we use UHPC? UHPC, it gives us shorter development lengths. We can have tighter joints, and it's a very strong material. Here's our shear connection where we were connecting basically the beam to the bottom of the panel. With the bulk tee, it's a 3.5 foot wide top flange, and so the top flange the whole area was filled with UHPC. We wanted a minimum of 4 inches of our beam stirrups to protrude into that UHPC, and we had a minimum requirement of 2 inches depth on the low side of the slope. Here we're setting panels. It took us 2 days to set the panels. We had 32 panels that needed to be set, and we were able to set 16 one day and 16 the next. As you can see on the panels here, they brought them in. They were set in place, and you can see in the picture there's lifting loops that was designed by the engineer, and there's also, you'll see these bolts again. These are adjustment bolts. This allowed us to basically almost preset the slope of the beam, so when they went in, they could just set the panel in place. They can adjust the bolts, and that would set our 2% cross slope. And the various holes you see in the top of the bridge panel there between the bolts, those were supposed to be pour holes and vent holes. And this will allow you to, if you needed to add additional UHPC or to let air out, this was the function of those holes. The UHPC that we used, we had 2 mixing plants on site. This allowed us to have a continuous pour with a batch being made every 15 minutes. And this allowed us to, once we started pouring, we could pour one side of the bridge, and it was probably a 12-hour day on the pours. Being that this was the first time the contractor used it, we were all in a learning phase here. What was the best way to move the UHPC from the ground to the bridge? And we actually, Lafarge Concrete was the supplier of the UHPC, and we had their mixers and their personnel on site to do all the QC testing. This is a closer picture of the mix going in. We had the UHPC is consisted of a bag of cement, and it's a 2,200 pound bag of cement. It's their ductile product. It has steel fiber bags, and you should be, when you're using this, you should be wearing some type of safety gear, particularly respirators and gloves and Tyvek suits. Being we were pouring this in July, it was 95 degrees the first day, and so it was pretty hot, so some of the guys didn't want to wear the Tyvek suits, but it is advised to use that because it does go everywhere. One of the other components is the amount of water you put into UHPC. The UHPC is very sensitive to your water, so you have to weigh out your water and your plasticizer, which gives you the strength of the with the UHPC. The water here, we were putting in a mixture of water and ice of about 130 pounds. Because it was a day of the temperature outside, we were putting about 80 to 90% ice into the mix so that we could mix, so the mix wouldn't get too hot while they were mixing in the mixers. And you see, we had a digital scale at their own site, and it's very important because you have to weigh everything out to have a backup scale, because a $50 scale could stop the whole project if you couldn't weigh it out. Here's a little quick video on how they actually test the mix. And what you see, it's sped up a little bit, but he does a 3-inch slump here, and he takes the temperature of the mix. For every batch that comes out, he'll take the temperature and he'll run a slump test on it. And it takes probably a couple minutes to do the actual test. And the initial slump here we're looking for is between 8 and 9 inches. And so he'll sit here and he'll time it, and then he'll come back in here, and with this little device, he turns it 25 times, and it'll bounce it, and then he'll remeasure it again. And so right now he's taking an initial reading, and now he's bouncing the UHPC, and we're trying to keep it between 9 and 10 inches. If it runs off that dish, it's a bad batch. We were actually placing the UHPC. The picture on the left is actually us pouring it during the day, and we actually had set up made some little wooden troughs to try for them to use, but the UHPC flows pretty well, but it flows on its own, and so if you try to force it, it doesn't really want to flow freely. And so the bucket they were using, they were able to take the crane and flow the bucket right along the top of the joint, and the UHPC was falling in the joint pretty nicely. And so they learned to use the bucket, and it worked pretty well. And so because of the temperature, the next pour we did in the evening, we poured from 6 to basically 5:30 in the morning, and that was much easier on the guys. It wasn't as hot, and we didn't have any issues. The UHPC poured really well, and you can see the picture there where the UHPC is basically falling right into the slot there, so they can control how much they open that bucket. In order to ensure that you have all your joints and your hidden pockets are full, you need to maintain your head pressure. And one way to maintain your head pressure is you can take a 5-gallon bucket and create a chimney, and you just attach it above an open joint, and you keep that UHPC, that bucket full with UHPC, and it'll keep running until it has nowhere else to go. And so you need to make sure that your joints are covered, because if you don't cover the joints, the UHPC will continue to flow, and it will push out any joints that you have open. So the way we could tell once a joint was completely full was the bucket actually started filling back up with UHPC. So we would remove the bucket, and then we would close up that hole and proceed down to the next joint. One of the things that took us the longest was just putting up the formwork to contain the UHPC. We had suggested that in our plans we had detailed using stiff styrofoam to form up between the top of the flange and the bottom of the panel, but the contractor was a little worried that it may blow out, so he decided to use wood, and it took 8 days for them to install all the wood forming and remove the wood forming. So that was in our time frame, that was probably one of the largest consumption of our days. And so, but once you see here, they were using 2x6s and 2x4s. They removed the side form and finished it, and it looks really nice once it's finished. They did contemplate that maybe next time they would use steel, but we still haven't figured out exactly how they would go back and using the steel, but that's something for us to think about and consider for our next projects. The end walls is typically just normal cast-in-place end walls. Again, we allow them to use a 24-hour celebrated concrete. And so doing the process of doing the end walls, removing the formwork, placing the backfill, placing the approach slabs, and doing the barriers on the bridge, this took about 9 days. And then the finishing touches on the bridge, we had to do our approach paving. We grooved grooved the bridge, did the final grading for the dry soils that we had on either side of the bridge, and then they striped the bridge for traffic. And this took about 3 days. So when all said and done, we had this bridge open up in 59 days, which was probably one of the quickest bridges that we've ever done in Georgia. That was a complete bridge, not any type of maintenance. So from start to finish, it was 59 days from date of road closure. And this is 59 days from the day we closed the road to the day we opened it up to traffic. But actually, it was only probably about 42 days of actual bridge work. We had some other work on the other end. There was a retaining wall that added a few days to it. But overall, it was the road closure included as well that 59 days included no Sunday work, some Saturdays they worked, and had a holiday in there. So when you take all those extra days out, it was ended up being 40, 41, 42 days. Now I'm going to turn it back over to Bill, and he can go over the lessons learned.
Well, I think one of the biggest things that we got out of it was one of the things that was real good is Dexter was involved with the construction through this construction. Not only did he design it and got the shop drawings approved, but I wanted him out in the field during all this construction so we could handle what was going on during construction, but also learn from it so that we can move forward. Like one of the things that we saw out there was the leveling bolts. The UHPC would bound to those leveling bolts, and the first ones that they tried to remove after the first day, there was no way to remove them. They were used an 8-foot long, I'd say, cheater bar to try to twist them out, and it wouldn't do it. Couldn't turn them. So when they came back in for the other half of the bridge, they let it set up for, I don't know, the first initial set, 6 hours or something, and then the contractor came back and he loosened the bolts, tightened them back down, left it overnight, and came back the next day, and they couldn't remove them. So we know that we've got to do something different on the leveling bolts. It was also good just to be part of all the and understand like 8 days to do to form the closure pores. Given another project, we reduced the time. The contractor's not going to have that luxury. He's going to have something to do faster in order to get this project done. One of the having this experience with UHPC is get that under our belts to work with them. And Lafarge was really good. One thing that we learned was, listen to them. The representative from Lafarge got in there. I know the contractor was pretty, had a lot of anticipation to get out there and get to working, but the Lafarge representative helped him with coming up with the buckets, putting the buckets on top and making sure you have that head pressure and all, and also the heat. They got out there that first day and it was too hot, and they had to switch it and go to a nighttime pours, and that was real important just for the time of year. In the mechanics of putting it all in there, one of the things that we got that the contractor, the way we had it detailed, is without the end walls in place. They could have easily had access with a buggy to get up on top of the bridge and put the UHPC, but because you didn't have that access, all the UHPC had to be poured by that bucket, which is time consuming, and just logistically you've got to work through. The larger joint openings, yes, we think that certainly the top joint, the where you're pouring in the UHPC, we definitely are going to make the width of it larger, make it easier for them to pour it in there. And also when we put that, we'll come back later and put the plywood on top. we're thinking that we might even, the next time we do it, we might even kind of raise it up just ever so slightly. When they come back and grind it, it'll just grind right off. It won't be a problem. Let's see, the cost versus benefit. Well, I mean, it wasn't, you know, this wasn't a project where you're doing it over 4 days or whatever, but 60 days was a huge win for us. You know, we did it in the summer months, but you know, it's not just proving it to ourselves. It's not just proving it to the contractor you can do it quicker, but it's also our field people. We had to convince them that, look, you know, this is something we can do. And I think that was big, because like Dexter said, we got done with it. We totaled up the day's work. We're at 41, so we know, you know, if I had a similar bridge, I'm not going longer than 40 days. And honestly, if we really want to get it done quicker, we need to just tell them to reduce the time. I mean, it should be that simple. But cost versus benefit. So typically, a single span bridge, Georgia's bridge cost, let's just say, looking at the typical bridge, is going to be around $100 a square foot for bridge replacement. That's just the bridge. And you can typically, with a single span bridge, you usually got to get a good overall cost when you factor in all the roadway costs. But since it's just a single span, that can be a little bit higher. I compared it to, I looked back at one of our conventional projects. The conventional project ran about $170 a square foot, just bridge cost, whereas this one was about $218 a square foot. So really, if you look at that, 28% increase to get this thing done in 2 months. That's huge. But when I compared the projects one-to-one, the first project overall, all the roadway costs was about $2.64 million. This project was bid amount was $2.68 million. So in this case, compared to the two projects, it's only 1.4% difference. So that's a shock to me. So I was pretty pleased with that. Tolerances, that's a big issue. We had some panels that weren't square. I mean, or they need to be rectangle. They had the edge distance that Dexter had on the plans, but when you went corner to corner, it was slightly out. Well, if there's a slight slope to it, and you start placing them, and you follow that, and you match the joints up all the way, you find out real quickly that your panels start walking off your bridge. And that was another reason it was good having Dexter out there and helping working contractor to take the first panels off, talk about it, figure out how to place the panels and make adjustments so that you worked your way across the bridge. And we learned a lot just you know, next time, you know, how we're going to approach placing the panels. But all in all, it was a very good project. In taking that, having that benefit too of being involved throughout the construction, we followed up at the end with a meeting with the contractor. We met at the contractor's office with our field people and walked through. They threw out everything that we did, and I mean, honestly, the contractor was still sitting there going, "Hey, I'd love to just give me the time and let me do it conventionally." And you know, I understand your point, but let's use these precast elements and don't give you the time and get it done quicker. And that's really the takeaway. But we're going to use this. I mean, we're going to use it in other areas of the state. So just wanted to put this out there that we did let this in July of 15, but the work didn't start. The bridge closure was a year later, June 1st of 16, when we got to that point. we couldn't have started when we let it in July. We couldn't have started anyway, and then we had all the shop drawings and coordination and everything ahead of time. So that was not bad. And we wanted to do it in the summer anyway. That was the time period that we were allowed to close the roadway. The contractor is local contractor E.R. Snell, and then E.R. Snell had Structural Engineering Solutions as that helped them with their construction engineering, and they worked real closely with us throughout the project. They really did a good job, and just wanted to tell who they are. Also, I will take a minute to say that I want to give some thanks to Dr. Kahn from Georgia Tech, who has done a lot of research with us, with our UHPC, and just overall experience and working with us as far as helping us, giving us advice, as well as Dr. Ben Graybill, who did take some time and answer questions and give us some pointers that ended up paying off in this project. So we really appreciate the help from both of them. Where we're going from here, we have I've got a couple projects that are similar. The first one, the Elliott Road, it's scheduled to be construction in fiscal year 19. We may deliver it sooner, I don't know, but fiscal year 19 is when it's scheduled. But we've got a contractor, a consultant working on it right now. It's American Engineers. It's going to be very similar to what Dexter did. It's right now it's a 145-foot single span using the precast deck panels. Dexter came up with the details as far as our panels go, so that the length of the panel ranged from 8 to 10 feet. All the reinforcements the same. So as long as you just change the length of them and calculate the number of panels you need, thinking they're using the same details, except for we'll improve on the joints from what we've learned, and we're excited about that project. We also have another project, Black Hall Road. It's another stream crossing. It's a 3-span bridge, and we're going to try to use deck bulb tees on that one. Looks like it'll be 54-inch bulb tees, I believe, with the casting, well, with already decked, and then we just come back with the UHP closure pours. That one is also scheduled for an FY19 letting, so that one will be a good project to work on. And then we also have another project that's that is a design build project that we're in the procurement phase right now. It will be let in this coming July. This project is the Cortlandt Street Bridge replacement in downtown Atlanta. It's metropolitan. I mean, it's right downtown. It's the state capitol is a block away. It's in the heart of Georgia State University, where there's buildings connecting to it. There's parking decks. There's pedestrians on top of it, below it. So it's a very tight workspace. But we've recognized the need to replace this bridge as quick as possible. So we're going out for the design build. We think our costing plans are going out as if it were likely to be a incremental launching. We're setting the road closure for Cortlandt to a total of 6 months. We're trying to make sure that we coordinate that between the summer months and their fall summer and or spring fall summer, excuse me, whatever. Also try to miss the legislative session. So it will be an interesting project. So that's our project.
Thank you, Bill and Dexter, for a very interesting and informative presentation on Georgia's ABC implementation. We got lots of questions before when you registered, and we got a number of questions that came in during the webinar. So Ben Bierman with FHWA will now moderate the Q&A session. Ben?
Okay, thanks, Mary Lou. And Bill, Dexter, great job on this. Folks, we have Dr. Ben Grayfield that's going to join in on helping out with the Q&A session as well. As Mary Lou said, we did receive a whole bunch of questions. I believe I counted over 60 before the webinar, and we have the questions coming in. I've got them categorized in these different groups: project planning, cost, design and detailing, performance, durability, fabrication, materials, construction, and of course time. So we'll go ahead and start off with some of the high-level project planning type questions. Let's see here. Let me get my spreadsheet set up. There we go. So for Bill and Dexter, what kind of criteria or evaluation process was used to select the use of the precast deck panels?
I don't think we had a formalized criteria, Ben. It was we were trying to it was minimize right of way and minimize the road closure. So there wasn't like a formal selection process.
Sure. And then with that in mind, and that was sort of your project goal there, was there consideration to use other forms of prefabrication and other elements of the bridge?
So we thought about using, going ahead and doing the abutments as precast. It might have, if you looked at the timeline, it's 7 days to do the abutments. But yes, we'd probably come back and do that in the future. We just kind of, schedule-wise, we didn't have time to get those details the way we wanted them.
Sure. And then you mentioned this during your presentation about the lead time. When you are going through the planning process, did you say to yourselves internally, because of the prefabrication components and some of the new innovations that are coming into the project, did you go into the project knowing that perhaps you need longer lead times from when you award the project to when you actually start construction out in the field?
We certainly did. You've got to be able to get you've got to have that lead time. The beams aren't quite such an issue, but it's that preparation that you have to do to make sure you have your site. You've got the workspace available, and the contractor's given thought to all that.
Okay. And what about the traffic management? What did you all do? Was that a complete detour, shutdown bridge type situation?
Yes, it was a complete off-site detour. We closed the road.
And how long was your detour? Yeah.
It was the 60 days.
Oh, I meant
how long? How long?
Yeah.
Maybe 15 miles.
And do you recall the ADT that you were dealing with, or roughly?
I don't know.
It's under 4,000
vehicles per day. 4,000 vehicles per day.
Okay. All right. And then in the contracting requirements, did you all put incentives, disincentive clauses in there?
So we put, all we did was we put liquidated damages in there. I think it worked out to be like $5,000 a day after the 60-day closure.
Yeah, sort of your standard liquidated damages, it sounds
kind of
like.
Standard, yeah.
So Georgia's GDOT's practices. So do you all typically use overlays or allow asphalt to go onto your bridge decks? And what was done on this job for the final riding surface?
So we don't. I mean, we've gotten away from using overlays as much as possible. We've kind of got a criteria where we try to eliminate. We've had a lot of bridges with asphalt overlays, and we've tried to eliminate that over time. In this case, we decided we didn't want to do an overlay. We considered like a two-part polymer overlay, but we really wanted to see how the ride was going to turn out, how the joints were going to look. We actually, Dexter and I went back out there last week. That's as you see now, the picture on the right is the picture we took the other day. But the joints look great. As far as the way the UHPC bonded to the precast panels, somebody asked a question about, did you see any type of reflective cracking through it or any type of leakage? And absolutely not. I'm absolutely 100% sold on UHPC. The joints look great. I like the way that Dexter had the picture from underneath where you could see the bottom of the deck panels and see the haunch board. It worked out really well. Looks good. So, no, and when they ground it, we had a grinder on it. He had to make two complete passes on it. It took him, it took a day, I guess, to grind the whole thing. He had to do a whole path, which was about an 1/8 inch, then come back and do another complete path, and it rides really well.
That's great. And then you answered that following question: was grinding done? Were there any difficulties with the grinding, with having the UHPC on the deck?
We were out there watching him. We're actually out there with him grinding, and I didn't see any real problem. I think with logistically at that point we didn't have the approach pavement out there, so contractor had to form up. I had to put some timbers out there for the grinder to drive off on. And that was really the only issue. But as far as actually physically grinding, we were concerned about that too. I've heard a lot of horror stories about UHPC and it's going to eat up a grinding machine and all that. We didn't see that. He just drove right through it, and it looks real good.
That's great. And Ben Graven might want to weigh in on that as well, because I hear that from designers, this concern of the grinding, but all the contractors that I talk to respond back and saying, if you have an issue with grinding UHPC, you'd have an issue with grinding just regular concrete. There's something going on there. And Dr. Gravel, I don't know if you can weigh in on that.
Yeah. It's still concrete. It's a Portland cement-based material. It may be a little more abrasion resistant than some concretes, but concrete as a whole, there's a lot of different abrasion resistances there. You've got different aggregates, different resistances. So UHPC might be a little harder, but it's not going to be huge.
Yeah, for a typical deck grinding piece of equipment. So, and probably this is the last question in sort of that project planning, decision making for Bill and Dexter. Were you guys looking at this particular deck strategy, the prefabricated deck panel with the UHPC, and kind of weighing in and deciding, well, should we do this or should we do just sort of the conventional precast deck panel with the post-tensioning strategy? And if so, were there indicators to say, we need to go this route versus the other?
So, we did. We looked at a number of things. We knew we wanted to go precast panels. That was at the onset what we were doing. We weighed back and forth whether or not we wanted to use the UHPC or conventional grout. I think that the best decision that we made was to stick with the UHPC, and it really, the material that we got is phenomenal. We did consider, we went back and forth about whether or not we wanted to pre-stress the panels or even come back in and post-tension, and we thought about running a little bit of longitudinal post-tensioning through them and just tightening everything down once the joints were poured. But in the end, we think that in the long run, I don't see a real benefit out of it, and it probably would have added an extra day or two to the work. So I think we made a good decision not doing that.
Sure. Bring in another operation, another specialty crew, and things of that nature.
Correct.
It's typical to see people coming in with either with a methacrylate or a deck seal type joint after the UHPC is placed and cured. Did you all do that on this particular job?
No, we didn't. Yeah, that was a consideration too, and even with other projects we're looking at, that's come up. But we didn't. We've had some cases where we've had some issues with other bridge decks. We've used methacrylate, but really wanted to see how this was going to perform without that.
And you all did the exposed, the aggregate finish on the panels, where the UHPC was contacting the precast.
Well, so no, where it's contacting to the beam. Is that what you mean?
No, where the UHPC is in contact with the precast panel. Was that finish an exposed aggregate finish?
It wasn't, but that is certainly a takeaway that we did gain from it. We will do that on our next set of panels.
Okay, and then for GDOT, and this is probably going up to the owners, were there issues with procuring the material? You know, from the perspective of the proprietary nature of the product, and maybe the perspective of the sole source component.
Well, we felt like we met the requirements because time worked out where the fibers are here in Georgia. Certainly, the big Lafarge is the biggest company that's around, and they did win the project, but there are other companies that can do it. But yeah, it was a concern to us. You know, when you have limited resources like that, you know it's going to end up costing more. But we didn't. There's a question in there about the cost of the UHPC itself. We had the cost embedded into the cost of the precast panels. I think in the future we may separate that. But we did work with the contractor, kind of getting an idea of how much the contractor was paying for the material. And yes, it's expensive. But as I mentioned earlier, comparing this project to a conventional deck and the overall cost, you know, it cost a little bit more, but in the end, it probably didn't cost us that much.
Yeah, not when you're looking at that total project and you come in, you've seen only a 1.4% spread. It's sort of like you're not even seeing it, you know, from that perspective. Okay.
Yeah. How many yards do we think we had? With 20 yards?
The UHPC was 42 yards.
42 yards, and I want to say the contractor threw something about $2,500 a yard.
About $2,500
was what the contractor was quoting us, which is a lot, but it's a small amount.
A lot, small amount, and the quality you get, and then there's that strategy of, well, you know, leaving it as a bare deck and other things come into play. Okay, so let's talk about the panels a little bit. The panels, were they made by a certified PCI plant, or was that done by the contractor?
It was done by a specialty contractor that was on our QPL, our qualified product list.
Oh, okay. Well, but was that out of a certified PCI plant?
Yeah.
Oh, they were? Okay.
Yes, out of a certified plant.
Okay. And then, was there any consideration, I guess this kind of answers itself, but anyway, I'm going to ask it anyway, any consideration of creep for the precast panels? Well, they weren't pre-tensioned or post-tensioned, so I guess it's a non-issue, correct?
Not that we observed.
Yeah. Okay. And I apologize. I'm going through the list, and I'm going, okay, there we go. Let's go into the construction type questions. We got a plethora of those, and they seem to be really good. Let's see here. There was a question about the seal boards. You showed the forming. There was a question about, well, how are the joint seal boards attached on the formwork picture you showed? Were they nailed to the deck, or were they just kind of wedged into place?
Pretty much they were wedged in place.
Well, they were, the form boards underneath had tap cons every 4 feet or so with the 2x6, and then they were also wedged in place with the 2x4 uprights. That's what the formwork underneath was, and then on top it was this wire nail attachment with the formwork on top of on the top of the panels for the closures.
And since you're talking about the top, did you do the 1/4 inch over pour on the top, or did you do that flat?
We did it flat, and that was something we know we want to go back and do next time to get that extra 1/4 inch, get a little extra, about a 1/4 inch or so extra poured, because you did get a little bit of air bubbles on the top of those joints. And the grinding took out most of them, but there's still a few spots that had, you can see little air bubbles. So if you do a little 1/4 inch over pour, it would definitely take out any, make it perfectly smooth out there. Should.
So you saw a little bit of air bubbles. Did you see any significant drop in the joint or a drop in the UHPC relative to the edge of the precast, or is it pretty much level?
It's level.
It's level.
Yeah. So it's really those those little bubbles that come on up to the top there. Okay. So there was a question about, and you talked about it. It's kind of neat that you guys used that underlip on the panels right there. And there were questions about, and you talked about it, someone. I don't know if you can elaborate a little bit more on it. It's when the panels were coming down in the alignment with the 4 corners. Were there any problems with cracking? Any issues with, we're going to have to break a bottom tab of the panel there?
No, not really. All the edges were free. The only issues that we had was during the fabrication, when they were precasting the panels and they were cleaning off the forms that created the shear keys, they broke some of the
Ears.
Some of the ears, or when they broke some of those, and we just had to, we told them, told the contractor, look, you gotta be careful with them, and they changed their procedure, and we didn't have any more issues after that. I mean, everything, those were fine putting those together.
It seems like if those tabs do break off, at least from the owner's perspective, they're just going to shore that. They're going to just form the bottom of it, and it's going to be filled with UHPC. Is that how you all kind of perceive that? As sort of a non-issue from an owner's perspective?
Yeah, exactly. I mean, and the UHPC was fine. It filled any of those imperfections in. It was good.
You actually have better material in the ear than you did before, even when they break it. It's kind of interesting. And it's at the bottom of the panel. Did the contractor like having those tabs at the bottom to kind of help, or would they have preferred to have seen sort of that open joint to where they have to come back and form it? Or did you get any feedback on that?
They like the bottom tab, but the top tab here, for that 2-inch joint opening there, that made it a little harder for them to pour in there. So they were fine with the bottom tab because it helped them keep it sealed without having to worry about any leakage from the grout. But with the top ears, the top tabs there, we're going to basically remove those, so you just have a 6-inch opening down for the lap of the rebar, and that will allow them to pour it in real easy. Because when we were pulling the transverse joints, it was kind of slow because they had to be a little precise about pouring it in. But when we poured our longitudinal joint had a 6-inch opening on the top, and that poured real quickly, and they were done with that in this, pretty fast. So they like having an open top, but the bottom they want that ear there. They want that tab to stay there.
Okay. So what about the quality assurance requirements? How was that handled with the UHPC from the owner's perspective?
Well, the Lafarge technicians were on site. Everything came from, there was 2 technicians on site making sure that the mix was mixed properly according to the ratios, and as well as the materials themselves came from, plants that Lafarge had, had their products, controlling the product. And the product came from 3 different places. So the question earlier was about, availability or logistics of it. It does take some planning to get all your materials there out the job site. But yeah, the Lafarge technicians were on site to make sure that we didn't put too much water in it. We had enough water that it wasn't too hot. And the only time we had a bad batch, it was because we had a thunderstorm roll through and it sat in the bucket a little too long and it didn't want to flow. So we only wasted one bucket or one batch that was mixed up. So the Lafarge guys were right on top of it the whole time. They were pretty good to have. And I think that's something that we are going to require is that whoever is the supplier of the material, they're going to have their technicians out there to ensure that the mix is being mixed properly and according to their list, to their rules.
So did you ask the contractor, require the contractor to do sort of a demonstration, mock-up, and was the training done with your inspectors? Was any of that kind of, we'll say, pre-training, just-in-time training efforts pursued for this project?
No, we didn't have a mock-up for them to show for, and I think that would have been very helpful for the contractor to know what to expect. When it came to the, having to have a chimney, came to having the extra lip on your joints, as well as the time to, what's required in the mix, how precise it had to be. Because the contractor came out on the day of the pour, we didn't have any buckets for chimneys, and the Lafarge people were saying, hey, got to get your buckets. So it's a good idea, I think, to have that pre-meeting, not just a pre-construction meeting, but just a pre-meeting just talking about the UHPC itself.
And we did have a pre-meeting, but we didn't go through the actual doing like you said, a mock-up and doing a dry run, I guess. We did not do that. We'll consider that next time.
Okay. And let's talk a little bit about the UHPC, some specific details there. You mentioned temperature. Are there temperature requirements of when the UHPC should be mixed and placed? And I don't know if Dr. Graybill can talk a little bit about that.
I'd be happy to. The general rule of thumb is that when you're placing the UHPC, it would be best to have it be not more than 80 degrees Fahrenheit. If the material gets too hot, it starts to get stiffer. It's hard to place, hard to mix, hard to place. So you want to keep it cool. Now, if you're doing a project in the summer in Georgia, you're going to want to do things like work at night, like was done in this project, or potentially use ice in the mix instead of water in order to keep your mix cooler by the time you'll be placing it.
Okay, and this one was placed at night, correct?
Well, the first day we were going to pour, we actually ran into a little hiccup because we weren't quite ready because they didn't have the chimneys, they didn't have all the formwork to cover the joints, the open joints on top. So we actually waited till the next day, and plus because the temperature, again, time we were getting ready to pour was going to be about 11 o'clock, and that day was already up to about 90 degrees, at midday almost. So second day we did pour in the day, but again it was 95 degrees, so the decision was made to do the second half of the bridge at night, and that was much better. It was still, in the 80s in the evening, low 80s, high 70s, but it was much better, and the UHPC flowed much better. We didn't have the ice issue where we had to put so much ice in it. During the day, we were having to put, like I said, about 80 to 90% ice out of the 130 pounds or so of water, where at night we were probably putting, about 60, 70% of ice. So it made a difference.
Okay, and what was the strength gain on your UHPC, or what was it spec'd at?
Well, the minimum spec of 21,000 PSI, but the 14-day break came back at 24. I think we had a 22, a 24, and a 25 break.
Okay. And the cure, did you guys use the 1212 or the, which I believe is the quick version of the UHPC, or did you use the more conventional mix that the Lafarge comes out with?
believe it was the 1212. It's within our spec.
Okay. And that's the kind of cure time it took for you all, roughly about 12 hours to get that strength gain?
Yes.
Okay.
I'm sorry. We did have a requirement that they couldn't put any machinery or any loads on the bridge until we had a minimum of 14,000 psi. So they were putting equipment on it, and this like 2 days later they had all the equipment, putting the barrier, stuff like that, onto the bridge. So it worked. It went pretty fast.
Okay. And then there was a question about the rebar itself. Was that just standard non-coated rebar? Was it galvanized, epoxy coated? And we're talking about the deck rebar that went into the joint itself.
Yeah, just standard mild rebar. No epoxy. Nothing else.
Okay. And then we're kind of running out of up to the 10 past the hour. I'll kind of close out with this question here. Contractors' feedback after the job was done using the UHPC and the deck panels. What was their take on the job overall?
I think they're pretty pleased with it. I think as going through the project all along, the contractor was trying to figure out a way how not to do it. I mean, not on this project, but figure out ways where they could get on another project, get by without doing it. But I think in the end, I think they're pretty convinced that it worked real well.
That's great. Good to hear. Well, there's a lot more other questions that came in as well, and I guess what we're going to have to do is get those posted up onto the web site. So with this, we'll go ahead and let Mary Lou close us out. So Mary Lou?
Thank you again, Bill and Dexter, for your excellent presentation and Q&A session. Thanks also to Ben Graybill for assisting on the Q&A panel, and to Ben Bierman, for moderating the Q&A session. We very much appreciate our FHWA partners. And thanks to each of you for your participation in today's webinar.